Alright guys, so today I'm going to make a video just going into a simple problem blind. Usually I take an opportunity to review the content of a problem before solving it just so I can ensure that I can provide you with the best explanation. But today I'm just going to go right into the problem and you can see my reasoning. I'm going to select an easy, so hopefully I don't get, you know, trapped in the death loop of not being able to understand what's going on and going down a dark rabbit hole. But yeah, I'm just gonna do a simple easy. Hopefully this is a simple easy, and you can kind of see and watch someone reason through how they're gonna solve something. Okay, so split the array. Sometimes titles reveal something about the problem. I know about array splits, so split the array, is that what that means? I have no idea. Okay, you are given an integer array nums of even length. All right, it's even length. That's interesting. You have to split the array into two parts, num1 and num2, such that nums1 length equals num2's length equals num's length divided by 2. Okay, so you have to split in the center? I don't understand. Okay, so this is weird because it's saying like they have the same length, and it's the length divided by 2, and if it's even, then when you divide them both, you're gonna get two arrays that are the same length, so I have to split it halfway. Okay, so this doesn't exactly make sense because this constraint is very strong. Nums1 should contain distinct elements. Nums2 should also contain distinct elements. So what do distinct elements mean? It means that for any element in the array, that's the only instance of that element existing, right? So it's distinct. Like, you're the only 7 in my whole array. Nowhere else in this array will I find a 7. Nums2 should also, they're both the same condition. Return true if it's possible to split the array, and false otherwise. So this condition is also a little weird, right? So I'm going to read the example and try to get a better understanding of how I would split this such that that's the case. Okay, so all right. So one of the possible ways to split nums is such that nums1 equals 1, 2, 3, and nums2 equals 1, 2, 4. Okay, false. The only possible way. Okay, so basically what this is saying, this first condition, is that I'm going to take my nums1, right? 1, 1, 2, 2, 3, 4. Is it sorted already? No, there's nothing about being sorted or anything like that. Okay, so 1, 1, 2, 2, 3, 4. And what I'm basically going to do is I'm going to create two new arrays, nums1, right, and nums2. Now, nums1 length equals nums2 length equals nums length divided by 2. So since this is even, you can always divide it by 2, right? Anything that even can be divided by 2, like cleanly, right, into halves, right? Because there's two halves, so you divide it by 2, you get the halves. It's going to be of size 3. And what I'm trying to do is figure out if I can, well, size 3 in this example, right? It's going to be n divided by 2, right? If this was n, this would be, n over 2, n over 2. So it has to be like this. And I have to find a way, if it's possible, to, take one element and, segment them in a certain way, right? Put some in nums1 and put some in nums2 such that I have two new arrays of size n divided by 2, and there's only distinct elements in each, right? So the way that this is going to work, right, is I take 1, for example, and I say, okay, 1 will go over here. I could try to put 1 over here, but that's not going to work, right? So it needs to go over here. And I take 2. I say, okay, I'll put 2 over here. That's good. I take this 2, try to put it over here. Not going to work. Put it over here, right? Take this 3, put it over here. Okay, take this 4, put it over here. All right. So, well, all I really did here, right, is if I see it 0 times, so I'm going to put this, count of x. The count of x, okay, is the number of times I've seen x. Yo puedo hablar español. I can speak English, and I can speak the crow's language. He's saying he really likes Leetcode, He's like, I love Leet. Okay, so the number of times I've seen x, okay? So that's what c of x represents. So, in this example, c of 1 would end up being 2, right? Because there's 2 1s in this system. Okay, C of 4 would be 1, right? Because there's only one C4 in this system, C4. Okay, now how does that articulate into this problem? Well, if we kind of just walk through what I did again quickly, right, you'll notice that the only thing I really did here, right, I'll just write out the whole thing here. 1, 1, 2, 2, 3, 4. 1, 1, 2, 2, 3, 4. Is I tried to put it in nums 1, okay? Then I try to put the next thing in nums 1, but if I already saw it in nums 1, I put it in nums 2, okay? And if I was to see another 1, for example, what would I have to do? If I saw a third 1, I try to put it in nums 1, I can't. I try to put it in nums 2, I can't. So the only thing I can do is say, sorry, there's nothing I can do here, right? There's too many 1s. I can put a 1 in nums 1, and I can put a 1 in nums 2, but I can't put a nums 1. I can't handle more than 2 of them, right? So for the only thing that matters in this problem is I can't handle more than 2 of anything. I hope that makes a little bit of sense, right? But like when I walk through this, right, like what happens in this next problem where it's just all 1s? Okay, so let's walk through. So, remember it's even, so I split it into 2s. Maybe this will make what I'm trying to say make sense. I see this one, I say, okay, I'll put you over here. That's fine, right? And then I see this other one, I say, I'll put you, and I can't because I've already processed that, right? So I put you over here. All right, I think my thing died, so it's fine. So I'll just start from here. Okay, the basic point here is if I take the count of something, right, and all I got to do is look at each num. I'll say the count of something is a default dict, so I'm going to just keep a count of how many times I've seen things, right? And I'll look at each num, and I'll just say, okay, for each num in nums, all right? It's really this simple, and I'll say, okay, if the count of this num equals 0, now I'm going to modify the code after this, but I'm doing this to kind of prove a point. Well, then I'm going to put it in the left system, right? Put it in the left array. I don't even need to make the arrays. Okay? And I'm going to say, okay, now I'm going to mark that I've seen it and it's in the left array. Else if C of num equals 1, all right, well, then I'm going to end up putting it in the right array. Right? C of num plus equal 1. All right. Otherwise, what does this mean? I tried to put it in the left array. I couldn't because there was already one of them. I tried to put it in the right array, but I couldn't because there was already one of them. So the only thing I can do now is say, sorry, I can't process this and return false. Now, of course, if you look at this, there's really no... What this really means is if it's 0 or 1, we're good. But as soon as it becomes 2, it's not good, right? Because this is the case where it's C of num is greater than or equal to 2. So this whole logic, right, I only did it this way to kind of showcase this idea of, okay, I'll put in the left one, right, then the left split. If I can't, I'll put in the right. If I can't put in the right, I have to return false. When does that happen? That happens when there's more than 2 of any element that I'm looking for. So this logic just comes down to this. And just make sure that at each number I'm increasing the count of what I'm seeing. And at the end, I just return true in the case that I've actually been able to successfully process anything, right? If I've been able to look at everything and say, okay, you go on the left. If I've seen you once, I put you in the right. If I've seen you more than twice, we're out. But if that doesn't happen ever, right? If I don't see anything more than twice, there's always a way that I can configure this, right? I can move one over here and move the other one on the other side. I don't need to actually figure out what that orientation is. I just need to look at it and determine, like, put in the left, put in the right, put in the left, put in the right. All right. Now I'm so confident about this, I'm going to submit it without even hitting the run. All right, so what is the run and space complexity of this? Now, the run, let's say n is the length of nums. Now, I'm a little worried about this because someone might have a little cheeky, smart, there could actually be an n log n timeout version of this, and n and constant space if you sort it and then you just look at the consecutive number of numbers that are the same, so you wouldn't actually have to log everything. So there is another way of doing this. That's n log n time and constant space, but I'm going to do the n time n space version. Okay, so let's say time is, well, we have to look at we have to create this dict that's constant time, and then we look at every n num, and then we do a comparison, which is amortized constant time, and then we, append to our little counter amortized constant time. So that's big O of n time. And then for space, well, we create this thing, and then we actually have to populate it as we go through the system, right? So for every element, we end up adding to this C dict, right? So this dict scales with the number of elements that we have. So that's O of n space. Okay. So should I humiliate myself and try to do the other one? I'm not going to, okay? But basically, you could also do this where you sort the system, and then you just count the consecutive number of numbers that are the same, okay? Now, you know what? Whatever. Bonus credit. Let's do this problem the other way. So this is the ONO space version of this. I just got a new Mac, and I can't figure out how you do stuff. All right, so the other way is you would do an in-place heap sort or some sort of n log n algorithm that doesn't use any additional space. And then you would say, okay, the first element I'll look at, because I'm just trying to find the counts of things, right? So I'll say C, my current number equals, actually, you don't need to do that. So do count of 1. We'll do for I in range 1 to length of nums. And I'll say, if nums of I equals nums of I minus 1, count plus equal 1. Else count equals 1. If count is greater than 2, return false, return true. So this is basically the same thing where if it's sorted, then my neighbor will be the same as me if it's the same as me, right? All the people that are together, right? When a system is sorted like this, right, your neighbors are always the same as you. If you know what I mean. If the system is sorted, then I can count the number of people that are the same as me by looking to my left, right? If I just look in a row, I could say there's 1 the same, 2 the same, 1 the same, 2 the same, 1 the same, 1 the same, right? Here I could say it's already sorted, so 1 the same, 2 the same, 3 the same, 4 the same, right? They're bunched together, right? When things are sorted, the ones that are the same are going to be bunched together, right? Because they're the same. So in a sorted system, they're going to be next to each other, okay? All right. This one I'm not as sure about. So it's much slower, right? But the space is better, right? Because for this is heap sort. So that's going to be constant space, n log n time. This is n time. So this is n log n plus n time, which is just scaled by n log n, right? So this would be the n log n version of the algorithm. All right, that's all I'm going to do for you guys. So hope you guys have a beautiful rest of your day. Bye-bye.